Welcome to solverfy.
We're asked to determine the x-coordinate of the centroid of this volume here. So it's kind of a slice, a wedge that's sliced at an angle. You can see it in the book. And they suggest that we can look at the height of the height y of the volume is proportional to the x-coordinate. Consider an analogy between the height and the water pressure on a submerged surface. Well, we could do that because, again, the water pressure changes linearly with the height or the depth. So we could look at it that way, but I'm not really. Basically, then we have to play some tricks and do some kind of funny business and try to make analogies to this and that, when really we can just do the math. And if we do and it's not that hard to do the math. So we need to define the surface, this surface here, okay, that slices the wedge, and then this surface here that slices it at an angle. And so this surface is simply y1 of x equals HA times x. Okay. This surface, this volume isn't really too bad because there's nothing that's changing in the z direction. So then we can get this surface, this plane here. So this is a plane, and then this is a plane, and this plane is defined by z1 equals 2b minus b over a times x. Right? So that's this plane that slices along that. And to get the centroid, we just need to do a long integral. And it's not that bad because it's just polynomials. So we need to integrate x over the volume, and we need to find the volume. So in the volume, we're going to go dy, dz, dx, because we have y and z in terms of x. So we can integrate this from 0 to y1 of x, and that just gives us x times y1 of x, which we have here. And then we can go from 0 to z1, that's a function of x, and so that gives us x times y1 of x times y2 of x, well, times z1 of x. So x times this times this. So now we have a cubic polynomial, and then we just integrate that from 0 to a. And we get that the whole thing is 5/12 a squared b times h. And down here, we can just do the same thing, but put a 1 in here. So we get this times this integrated from 0 to a. And that gives us 2/3 a, b, h. And the ratio of those two things is our centroid away from this axis, and it is 5a all over 8. So it really only depends on a. Right? So however long this is, it's going to be move away. It's going to be 5/8 of however long this is.